Hello everyone, welcome back to our channel. In this video, we'll be seeing about the question paper and scheme and the mark split up for Introduction to Electronics and Communication, that is BESCK 204C. So coming under module 1, what is regulated power supply? With neat diagram, explain the working of DC power supply and mention the principal components used in each blocks. And B question is about the amplifier. And C question is with neat diagram and waveform, explain full wave bridge rectifier. In our choice, we have voltage regulator, and you have to draw that in a neat circuit diagram, explain the operation of voltage regulator using Zener diode. And next is mention the advantages of negative feedback in amplifier circuit. With the relevant equation and diagram, explain the concepts of negative feedback. And last question is, what is voltage multiplier? With circuit diagram, explain the operation of voltage doubler. So for each of the question, there is a mark 848. So how you can obtain this 8 marks can be split into various forms that we are going to see. Now if you see here, 1A question for regulated power supply, when you give the definition, it is 1 marks. What is regulated power supply? And for block diagram, it is 3 marks. This is the block diagram that you will draw. That is how from step down transformer, you will use rectifier, filter to filter all the pulsating DCs, and then you will get a smooth DC out of smoothing filter and voltage regulator and to the output. So this block diagram contains 3 marks, and when you explain this block diagram completely, then for the explanation you have 4 marks. Totally it is 8 marks. Then next question, amplifiers. So if you write definition of amplifier, you will have 1 mark, and you have to list down the types of amplifiers: AC couple, DC couple, large signal, small signal amplifier, audio frequency, wide bandwidth, radio frequency, low noise frequency. All these you have to list it down and explain each of these types in one word. So totally that carries 4 marks. Sorry, 3 marks. So totally it is 4 marks. And C, what is next question is full wave bridge rectifier. So the circuit diagram alone consists of 3 marks. So you have to neatly draw it. And when you explain the working of the full wave rectifier, that explanation carries 3 marks, and waveform carries 2 marks. So totally it is 8 marks. Next, 2A question is voltage regulator. So the definition of voltage regulator will be 1 mark, and the circuit diagram for voltage regulator will carry 2 marks, and explanation how it has been regulated. So the complete explanation with the circuit carries 4 marks. So totally it is 7 marks. And B question is about negative feedback. So negative feedback, what are all the advantages of having the negative feedback? The advantages you have to list it down, which carries 2 marks, and you have to draw the diagram for negative feedback, which is 2 marks, and then explanation for that particular diagram carries 2 marks, and equation AF is equal to AV plus 1 beta AV. So with feedback, how you will calculate the AF. So that is for 1 mark. So totally it is of 7 marks. Then 2C question was voltage multiplier. Definition of voltage multiplier is 1 mark. Diagram, that is circuit diagram for it, carries 2 marks, and explanation for that diagram carries 3 marks. So totally it is of 6 marks. Next, coming to the module 2, you have what is op amp and explain various parameters of op amp. Here next is you will be determining integrator, voltage follower, and comparator. And C question is 3-stage ladder RC network oscillator with neat diagram. Or choice will have explain Barkhausen criteria for oscillation. In Weinbridge oscillator, they have given the capacitor value and the resistor value. You will be determining the frequency of oscillation. And next question is explain the operation of single stage astable multivibrator with its circuit diagram. And then last question is ideal characteristics of op-amp. Coming into the scheme, you have definition for op-amp, 1 mark, and the parameters that require for designing an op-amp. All those parameters you have to list it down and write in detail, which carries 6 marks, so totally it is of 7 marks. And next question is about integrator, comparator and voltage follower. So each of the integrator, comparator and voltage follower, you have to draw the circuit and waveform, explain it. So all totally carries 3 marks, 2 marks and 2 marks. So totally it is of 7 marks. And C question was, for the circuit diagram, it carries 3 marks, and for the frequency determination, it carries 1 by 2 pi root of 6 RC. So when you determine this, you will obviously tell how you are calculating the frequency, which carries 1 marks, and explanation for this circuit diagram carries 2 marks. So totally it is of 6 marks. And next is fourth is according to the criteria Weinbridge oscillator. So what this criteria means, that is 3 marks. So total, how is the total phase shift? What is the closed loop gain? All those when you write it carries 3 marks. And Weinbridge oscillator, there was a problem where resistance value and capacitance value was given to calculate the frequency. So frequency is equal to 1 by 2 pi RC. So based on that, you will substitute the resistor value and the capacitor value totally to give the frequency in kilohertz. Then B was, for the circuit diagram it carries 3 marks, and for waveform it carries 1 mark, and for the explanation of the circuit diagram it carries 3 marks. So the expression, that is astable amplifier, so for that explanation carries another 1 mark. So totally it is of 7 marks. And final question is about how an offset input, what is the input offset voltage, and you have to determine the 6 criteria which carry 6 marks, and what is Ri, Ro, bandwidth and slew rate, all those you have to determine each in one sentence. So each of that when you determine and give it in sentence and the expression, so totally it carries 6 marks. Module 3, in this video, module 3, first half I will be explaining, and the second half of the module 3 I will be covering in the next upcoming series of video. So here module 3, convert the following. So they have given the binary value or hexadecimal value to convert into base 10, base 8, base 2, right? So and the second one is you will be determining state and prove De Morgan's theorem with its truth table. So you will be writing what is De Morgan's theorem and the truth table with it. And C is implementing the Boolean function using logic gates. So here they have given the expression. With this you have to determine the logic gates. So now coming into the scheme, 1AD.E0, that is it is base 16, and what is the value when it is base 10? So you have to multiply each of the value into in the form of 16, that is point E0. So what it is after point E0 will be 16 to the power of 0, 16 to the power of minus 1. Before it, 16 to the power of 1, 16 to the power of 2, 16 to the power of 3. Like that it keeps on going. So after substituting the value, for the same thing, 37.625 base 10, it should be converted to binary. So divided by 2, you will get an answer. And the same value 110, 100, 111, this you have to convert it. The answer, final answer will carry such marks. So likewise, you have to determine whether it is hexadecimal, octal or binary, which form it is, you have to convert it to the particular form. So totally it carries 8 marks. B question is complement of the product is equal to sum of the complements. So here you will be determining the De Morgan's law. So you will determine the De Morgan's law and you will prove how this particular expression has come with the help of the truth table. And finally here you have an expression, you have to determine it using logic gate. So x y dash plus x dash y is, x you will be putting in the straight line and y dash is nothing but not of y, so not gate, then you will be adding it, then that value will be given to the OR gate. This is how you will do. So this is AND gate, this is OR gate. You will be multiplying x y dash, then totally plus this one, right? Like that. If you draw the circuit alone, it carries 3 marks, so totally it is of 7 marks. Hope you have understood the concepts, like how to present your paper and how the mark split up is. We'll see the next series of video which carries module 3 second half, module 4 and module 5. Thank you.